Okay, so if someone hands you Tesla tomorrow, not a Tesla car, the entire company, the factories in California, Texas, Berlin, and Shanghai are yours. The supercharger network is yours. The battery business is yours. The self-driving software, the robotaxi operation, the Optimus robots, and every vehicle waiting to roll off the production line now belong to you. At first, the situation looks almost impossible to lose. Tesla delivered more than 480,000 vehicles in the second quarter of 2026 alone. Its cars travel on roads across North America and Europe. Its charging connector has been adopted by major manufacturers. Its brand is recognized almost everywhere, and investors value the company as if it might one day control far more than the electric car market. You own one of the most famous companies on Earth, so you must be very rich. The honest answer is yes, at least on paper. But owning Tesla would also mean controlling a business attempting to manufacture cars, build batteries, operate a charging network, sell electricity storage systems, develop autonomous vehicles, train artificial intelligence, and create humanoid robots at the same time. Every one of those businesses requires enormous amounts of money. And the most important parts of Tesla's valuation depend on products that are either still developing, operating at limited scale, or may take years to generate the profits investors expect. Tesla's present business is mostly automobiles. Its future story is almost everything else. Understanding the company means understanding the enormous financial gap between those two realities. Let us start with what Tesla actually sells today. In 2025, Tesla generated approximately $94.8 billion in total revenue. About $69.5 billion came from the automotive business, including vehicle sales, leases, and regulatory credits. Another $12.5 billion came from services and other activities, including used vehicles, repairs, insurance, replacement parts, and paid supercharging. The energy generation and storage division contributed approximately $12.8 billion. That means Tesla is not merely an automobile company, but automobiles still generate most of the money, and this creates the central tension inside the business. Investors are excited about robotaxis, artificial intelligence, and humanoid robots. But the cash required to pursue those ideas still depends heavily on Tesla manufacturing and selling hundreds of thousands of cars every quarter. Before Tesla can become the company of the future, the car company of the present has to keep paying the bills. So let us follow the money through a Tesla vehicle. A customer opens the Tesla website, selects a model, chooses the color, adds optional features, and pays a deposit. Tesla is unusual because it sells most of its vehicles directly, instead of relying on the traditional independent dealership system used by many automakers. Ford, Toyota, and Volkswagen typically manufacture vehicles and sell them through dealer networks. The dealer purchases inventory, operates the showroom, negotiates with customers, and carries part of the cost of holding unsold cars. Tesla keeps more control. It controls the website, pricing, stores, delivery centers, and much of the customer relationship. This eliminates the independent dealer's share of the transaction, but it does not eliminate the dealer's work. Tesla must operate its own retail locations. It must arrange deliveries. It must finance inventory, handle trade-ins, provide service, and build the physical infrastructure required to support customers. Direct sales remove a middleman. They also move the middleman's responsibilities onto Tesla. Then comes manufacturing. A modern Tesla contains thousands of individual components: battery cells, semiconductors, motors, cameras, screens, structural castings, seats, glass, wiring, suspension parts, and specialized software. Every component needs to arrive at the correct factory in the correct quantity at the correct time. If one inexpensive part is missing, a vehicle worth tens of thousands of dollars may be unable to leave the production line. This is why automobile manufacturing is one of the most capital-intensive businesses in the world. You do not simply design a car and start selling it. You acquire land. You construct enormous buildings. You purchase stamping presses, casting machines, paint systems, robots, and battery equipment. You hire thousands of employees. You qualify suppliers. You build logistics networks. You conduct crash tests and meet different regulatory requirements in dozens of countries. Then you repeat the process every time you introduce a significantly different vehicle. Tesla's answer has been scale. The company attempts to reduce the cost of each vehicle by producing huge numbers of similar models on highly automated production lines. This is why the Model 3 and Model Y are so important. They simplify the business. Fewer high-volume models mean fewer unique parts, more purchasing power with suppliers, and longer production runs. The factory becomes faster as workers and machines repeat similar processes. But concentration creates risk. If customers lose interest in the Model 3 or Model Y, Tesla cannot instantly replace that volume with 10 equally successful products. Traditional car companies often spread demand across numerous brands, engines, body styles, and price categories. Tesla's product range is narrower. Efficiency and dependence come from the same decision. In 2025, Tesla's automotive sales revenue fell approximately $9 to $65.8 billion. Total automotive revenue, including leases and regulatory credits, declined around $10 to $69.5 billion. Total automotive revenue, including leases and regulatory credits, declined around $5 billion. The company delivered fewer vehicles, and the average selling price was pressured by product mix, incentives, and financing offers. This reveals something important about the car business. Revenue can be enormous while margins remain vulnerable. If Tesla reduces the price of a vehicle by $3,000, that discount does not come out of some imaginary marketing account. It comes directly out of the economics of the car, unless manufacturing costs fall by a similar amount. Multiply a $3,000 reduction across 500,000 vehicles, and you are discussing $1.5 billion. Price cuts can protect market share and keep factories busy. They can also destroy profit remarkably quickly. Factories create another problem. They're expensive whether they are operating at full capacity or not. The building still exists. The machines still depreciate. Salaried employees still need to be paid. Maintenance continues. Property cost, utilities, and support operations do not disappear simply because demand weakens. When production volume falls, those fixed costs are spread across fewer vehicles. The cost per vehicle rises. This is why automakers often continue producing cars even when demand begins to soften. Stopping the factory can be more expensive than discounting the product. But discounted vehicles create inventory pressure, lower resale values, and train customers to wait for the next price reduction. There is no painless option. Tesla's automotive gross margin was approximately 17.8% in 2025, down from about 18.4% the previous year. That does not mean Tesla earned 17.8 cents of final profit from every dollar of automotive revenue. Gross margin is calculated before research, corporate administration, and many other operating expenses. After all expenses, Tesla reported approximately $3.8 billion in net income on $94.8 billion of total revenue in 2025. That is still a profitable company. But it is not the infinite margin software machine that its most optimistic future sometimes suggests. At least not yet. Now we reach one of Tesla's strangest revenue streams: regulatory credits. Governments in several markets require automakers to meet emissions-related targets. A manufacturer selling large numbers of zero-emission vehicles can generate credits. Other manufacturers that do not meet the required standards may purchase those credits to comply with regulation. Tesla sells these credits. In 2025, regulatory credit revenue was approximately $2 billion. The incremental cost of selling an already generated credit can be extremely low. That makes this revenue disproportionately valuable to profit. Tesla is effectively monetizing the fact that competitors have not moved quickly enough toward lower emission fleets. But this business has a built-in expiration risk. As competitors sell more electric vehicles, they may need fewer credits. Governments can also change the regulations that create the market. Tesla's regulatory credit revenue fell by approximately 28% in 2025, partly because of regulatory changes and changing demand from other manufacturers. This is profitable revenue. It is not revenue Tesla can control forever. Then there is the supercharger network. At first, charging stations looked like infrastructure Tesla needed to sell cars. Customers would be reluctant to buy electric vehicles if they could not travel long distances or charge reliably. Tesla therefore built fast-charging locations along highways and inside major cities. The network reduced a customer's fear of running out of power. That helped sell vehicles. But the supercharger network is gradually becoming a business of its own. Drivers pay for electricity. Other automobile manufacturers have adopted Tesla's North American charging standard in certain markets. Non-Tesla vehicles can access an increasing number of locations, and third-party businesses can purchase superchargers, set charging prices, and allow Tesla to operate the software and network. Tesla can therefore earn money from drivers who never purchase a Tesla vehicle. The charging network also strengthens the main product. A customer choosing between two electric cars may prefer the one connected to the larger or more reliable charging system. This creates a network effect. More Tesla vehicles justify more chargers. More chargers make Tesla vehicles more attractive. Opening the network to other brands generates additional usage while strengthening Tesla vehicles more attractive. Opening the network to other brands generates additional usage while strengthening Tesla's position as an infrastructure provider. But charging is not free money. Tesla must purchase equipment, secure locations, connect stations to the electrical grid, maintain chargers, provide customer support, and sometimes pay expensive demand charges based on peak electricity use. A busy station in the correct location can be valuable. An underused station is an expensive collection of equipment sitting beside a parking lot. Now consider software. Every Tesla is not just a car. It is a connected computer that can receive updates remotely. This allows Tesla to sell features after the vehicle has already left the factory. A customer can purchase connectivity, performance upgrades, or access to full self-driving features through the car or Tesla application. This is financially attractive because software behaves differently from a physical vehicle. Manufacturing another car requires steel, batteries, labor, shipping, and a factory. Selling a software feature to an existing compatible car can have a much lower incremental cost. The same software can potentially be delivered across a large fleet. This is the margin structure investors want. Sell the hardware once, continue earning from the customer afterward. But the name full self-driving creates expectations that are far more difficult than selling entertainment software. Autonomous driving must operate safely across unpredictable roads, weather, construction zones, pedestrians, emergency vehicles, and human drivers who do not behave according to clean computer models. The system also faces different regulations across states and countries. Laws written around human drivers may restrict vehicles designed to operate without one. A software update can be distributed quickly. Regulatory approval cannot. And one serious failure can create investigations, lawsuits, and public distrust across the entire system. This leads to robotaxi. The economic promise is enormous. A privately owned car spends most of its life parked. A robotaxi could operate for many hours each day, generating revenue from repeated passenger trips. Instead of earning money once when the vehicle is sold, Tesla could earn money every time the vehicle moves. Imagine a fleet of autonomous vehicles collecting fares without requiring a paid driver. Labor is one of the largest costs in the taxi and ride-hailing industries. Remove or reduce that cost, and the economics could change dramatically. Tesla launched a limited robotaxi service in 2025, using Model Y vehicles and plans to introduce the purpose-built Cybercab. But here is the gap between theory and operation. A robotaxi fleet needs more than self-driving software. Robotaxi fleet needs more than self-driving software. Vehicles need cleaning, they need charging, they need tire replacements, repairs, insurance, remote assistance, and secure places to wait between rides. Someone must manage accidents, lost property, vandalism, and passengers who become ill inside the vehicle. The driver may disappear. The operating costs do not. And before robotaxi can generate massive profits, Tesla has to spend massive amounts building the system. The company expects capital expenditures to exceed $20 billion in 2026, driven heavily by artificial intelligence infrastructure, data centers, manufacturing lines, Cybercab, robotics, and company-operated autonomous assets. Compare that with 2025, when capital expenditure was approximately $8.5 billion. Tesla is preparing to spend more than twice that amount in a single year. This is not a small product experiment. It is one of the largest corporate investment programs on Earth. If robotaxi works at enormous scale, the reward could be extraordinary. If adoption is slow, regulation delays expansion, or the technology requires more human supervision than expected, billions of dollars may remain tied up in infrastructure that produces less revenue than investors hoped. This is the fundamental nature of Tesla. The company repeatedly spends today for a future that may be much larger than its current business. Now we need to talk about the part of Tesla that receives less public attention but may have some of its strongest economics: energy storage. Tesla sells the Powerwall for homes and small businesses and the Megapack for utilities, industrial customers, and large electrical grid projects. A Powerwall allows a household to store electricity from solar panels or the grid and use it later. A Megapack performs the same basic function at a vastly larger scale. This matters because electricity supply and demand do not always happen at the same time. Solar panels produce power when the sun shines. Wind generation changes with weather. Electricity demand can peak in the evening when solar output is falling. Batteries allow energy produced earlier to be stored and released when the grid needs it. As electricity demand grows through data centers, artificial intelligence, electric vehicles, and general electrification, grid storage becomes more valuable. In 2025, Tesla's energy generation and storage revenue increased approximately 27% to $12.8 billion. The division's gross margin reached about 29.8%, substantially higher than Tesla's automotive gross margin that year. In the first quarter of 2026, Tesla reported an energy generation and storage gross margin of approximately 39.5%, compared with roughly 21.1% for total automotive. One quarter does not guarantee the future, but the comparison is striking. The part of Tesla most people rarely see may have stronger gross margin economics than the famous cars. During the second quarter of 2026, Tesla deployed approximately 13.5 gigawatt-hours of energy storage products. That business benefits from scale, lower battery costs, and growing demand from utilities attempting to stabilize electrical grids. It also carries risk. Battery prices fluctuate. Projects require permits and grid connections. Tariffs affect material and equipment costs. Large installations have long sales cycles and contractual milestones that can make revenue uneven. But energy storage is not a distant concept waiting for autonomous driving approval. It is already a multi-billion-dollar business. Then there is Optimus. Tesla's proposed humanoid robot is designed to perform physical work that humans currently do. The vision is easy to understand. Factories, warehouses, and eventually homes contain countless repetitive or physically demanding tasks. A useful general-purpose robot could become an enormous market. But building a robot that walks during a controlled presentation is different from building millions of reliable machines that can work safely beside people for thousands of hours. The hardware must become cheaper. The hands must become more capable. The artificial intelligence must understand unpredictable physical environments. The machines must be manufactured, maintained, and trusted. Optimus might become one of Tesla's largest products. It might also consume years of research spending before producing meaningful revenue. Today, it belongs more to Tesla's valuation story than its income statement. This distinction is essential. Tesla's financial statements describe the business that exists. Tesla's market value reflects what investors think may exist later. Those are not the same company. The existing company earns most of its revenue by manufacturing cars. It operates factories, delivers vehicles, services customers, sells batteries, and collects income from charging, software, and regulatory credits. The imagined future company operates autonomous transportation networks, sells artificial intelligence, supplies electrical grids, and manufactures humanoid workers. The existing business must finance the journey toward the imagined one. And that journey is expensive. Tesla ended 2025 with approximately $44 billion in cash equivalents, and investments. It generated approximately $14.75 billion in operating cash flow during the year. That gives the company financial strength. But spending more than $20 billion on capital projects in 2026 could push free cash flow under significant pressure, particularly if automobile margins weaken or demand requires further price reductions. A normal automaker can focus on the next generation of vehicles. Tesla is simultaneously trying to build new vehicles, new battery factories, artificial intelligence data centers, autonomous fleets, charging infrastructure, and robots. Ambition creates opportunity. It also creates competition for money inside the company. Every $1 billion directed toward robotaxi is $1 billion that cannot simultaneously be used for a cheaper mass-market vehicle, a new service center, or a larger battery factory. Management must decide which future deserves funding first. And no spreadsheet can guarantee the correct answer. This is why Tesla creates such extreme disagreement. One investor looks at the company and sees an automaker facing price competition, aging products, expensive factories, and aggressive Chinese rivals. Another sees the physical platform for artificial intelligence, millions of connected vehicles collecting data, a global charging network, large-scale battery production, autonomous driving software and manufacturing expertise that could eventually produce robots. Both investors are looking at the same company. They are simply valuing different years. If you believe Tesla will remain primarily a car manufacturer, its economics must eventually be compared with other automobile companies. That means vehicle volume, pricing, manufacturing cost, market share, and automotive margins. If you believe Tesla will operate huge robotaxi fleets and sell millions of robots, the car business becomes only the first stage of something much larger. The problem is that the future has to arrive before the spending overwhelms the present. This is the equation at the center of Tesla. Cars generate the majority of today's revenue. Energy storage is growing faster and can produce stronger margins. Software offers the possibility of recurring income. Charging creates infrastructure advantages. Robotaxi promises fleet-based revenue. Optimus promises an entirely new labor market. But factories, batteries, artificial intelligence chips, data centers, and robots require billions of dollars before they generate anything. The richest version of Tesla is not the company that sells the most cars. It is the company that uses those cars to build an ecosystem. Customer, businesses, and electrical grids continue paying to use. The next time you see a Tesla on the road, look beyond the vehicle. Look at the charging station it may use. Look at the software running inside it. Look at the batteries Tesla sells to homes and power companies. Look at the data centers training autonomous driving systems. Look at the robotaxi fleet Tesla hopes to build and the humanoid robots it wants to manufacture. Because the car is not the entire business, it is the machine currently financing the rest of the ambition. And if that ambition works, Tesla may eventually become far more than an automaker. But if it does not, you still own a company spending more than $20 billion in 1 year while depending heavily on a small number of car models operating inside one of the most competitive industries on Earth. That is the economics of Tesla.